What we did right now is we went outside to go and use the kilometer. We're going to do this activity on the next class. Okay? But right now, let's have you watch this video. Showing. Okay. Wow.
Sometime between 600 and 590 BCE. His father was Mnesarchus, an international merchant from Samos, a Greek island in the Parthenos, a Greek Apollonian. While traveling abroad near Delphi in Greece, Parthenos requested Mnesarchus visit the oracle to Apollo. The oracle informed the couple Parthenos was pregnant with a male child, and instructed them to abstain from relations during the pregnancy. Parthenos changed her name to Pythesis, but no record exists of her surviving the birth of her son, Pythagoras. Pythagoras traveled extensively with his father Mnesarchus during his formative years. Mnesarchus raised Pythagoras into the Median Persian cult of Zoroaster, the prophet and son of Ahura Mazda, the god of light. It is widely believed that Pythagoras was also initiated into the other religious cults of his day in all the lands he and his father traveled. These included, according to some, the Eleusinian mysteries of the Attica Peninsula, the Egyptian mysteries of Thebes, the Babylonian mysteries in Chaldea, and the cult of Adonis in Syria. Some believe it was from the Babylonian priestcraft while a prisoner in Chaldea. That Pythagoras studied the theorem that he would later become most famous for inventing. The theorem for all right triangles that a squared plus b squared equals c squared. Although the cause and date of his father's death remain unknown, it is recorded that Pythagoras himself traveled as far east as modern Afghanistan, where the Brahmins of Elephanta and Laura in Hindustan called him Yavanshara, the Ionian teacher. Pythagoras finally settled in Samos, his father's home, where he lived until the age of about 35 under the rule of the tyrant Polycrates. Around the year 550 BCE, Pythagoras went into self-exile from Samos and founded a university of mathematics in Croton, Italy, where he lived and taught for around 20 years. By about age 55, Pythagoras' school had gained significant enough political influence in the Council of 1000 who ruled Croton. That when one of their politicians, history reports his name is silent, although this is only a pseudonym for the younger mathematician Hippasus, refused to communalize his property, his discovery of this work of two, was the cult of Pythagoras, and was thus rejected from cult membership, thrown off a boat to be exact. Hippasus appealed to the Council of 1000 to have Pythagoras tried for criminal conspiracy against the state. Pythagoras fled Croton somewhere between 530 and 495 BCE, narrowly escaping a fire set by Hippasus at a log at Pythagoras' wife Milo's house, with his disciples Archippus and Lasus. He fled from there to Rhegium, Italy, a port town near the island of Sicily, where he parted with Archytas of Tarentum, another disciple, and from there set sail to Metapontum, in northeast Italy, the hometown of Hippasus, his would-be assassin, and took refuge in the temple there. He lived on sea cucumbers and honey until he eventually died of starvation in about 494 BCE, at around the age of 100 years.
All right, so hopefully everybody understands angle of depression and angle of elevation when we're looking at objects. Okay. Now we're going to follow these steps to try to solve some problems. Okay. Read and understand the problem. What do you know about it? This is something that I've been referring to as we've been doing some problems. And then make sure, what is it do you want to find out? Okay. The next thing that you should do when you're solving a problem is try to make a plan to solve it. Then go ahead and solve your problem, and then check your answer to see if any mistakes were made. Okay? All right, so we're going to take a look at this problem right here. A 100-foot building casts an 88-foot shadow. What is the angle of elevation of the sun? So what we're going to do here is we're going to draw some objects. So first we're going to draw the first part, a 100-foot building. Now, we only have enough room here to fit the building in this amount of space here. So let's pretend we've got a building that's 100 feet. Alright, so go ahead and draw your little building. And it says the building casts an 88-foot shadow. So assuming your sun is over here on the left side of the building, the shadow should be where then? On the other side, right? The shadow cast is about 88 feet long. Okay. What is the angle of elevation of the sun? So what we have in here, if you look at this drawing carefully, we have a right triangle
we have a side that measures 88 feet. We know the building measures 100 feet. Now, for those of you that may not know this, that little one that's written like an exponent it's feet. If I put 2 of those, that means inches, okay? Now, what I want to do is I want to find out what is the angle of elevation. Now remember, angle of elevation is looking up, right? Somewhere looking up. We're going to find out this angle. Now, with the Pythagorean theorem, you notice that the 100 feet is given, the 88 feet is given. If I wanted to find this length right here, I would use a squared plus b squared equals c squared, right? But that's not what the problem is asking us for, okay? The problem is asking us for what is that angle of elevation. And this is where we're going to start to learn about so on, okay? All right. So when you're doing SOHCAHTOA, you have to use specific types of tools. So we have to get SOHCAHTOA.
Yeah, you know what it is. When I do math, I do it. Yeah, if that's nothing. When I'm doing math, that's nothing. When you see me in the class doing math, I'm using the put it down. In the dreaming skills, or you're gonna lose. Science opposite of what hypotenuse. Why you look confused? Which one you gonna choose? For science to know what hypotenuse. We're not plugging in, don't get complacent. Tangent is opposite over adjacent. Yeah, you know what it is. When I'm doing math, I do it big. Yeah, if that's nothing. When I'm doing math, that's nothing. See me in the class doing math, I'm using SOHCAHTOA. Put it down, from the white book to my notebook. SOHCAHTOA. Yeah, I'm using SOHCAHTOA. Attacking these problems like rocky balboa. Geometry, till I feel I shout out to my brother,
All right.
Toss it, Shaq.
Shout outs. All right. So, we're going to use what?
Alright, so right now it's SOHCAHTOA. Now before we start using it, we gotta know how to use the calculator. So go ahead, everybody, turn on your calculator. And I'll put it over here so you can see me better. First thing we want to always make sure we do when we use this calculator, if your calculator has a graph on it, just hit clear. If you have anything on there, you can hit clear. What I want to do right now is introduce to you guys this button over here. That's the second button. It's a little blue button. Does everybody see it? Go ahead and press that once. And now go ahead and press the plus button down here. All right. And does this screen pop up for you? Yeah. Yeah? Okay. You're going to hit 7 or scroll down to 7 and hit enter. Either way, doesn't matter which one you choose. You can hit 7. And then this screen will pop up. Yeah. Now we're going to make sure we set all the RAM. So we want to hit 1 or enter. And then it's going to make sure, are you sure you want to do this? And yes, we do. So we want to hit 2 or scroll down to 2 and press enter. And then you'll see that screen say RAM cleared. We typically want to do this just in case some of my other classes I have Algebra 2 that is using the same calculators, and they're going to start going into pre-calculus pretty soon, and we have to jump around from mode called degree mode and radian mode. Okay? What we need to make sure is that we're always in the right mode. So everybody see the mode button right next to the blue button second? Press the mode button. And you guys notice it's got a bunch of stuff in there. If you scroll down, do you guys see the box that's blinking? Scroll down till the radian is blinking. Right now it's in radian mode. We're not going to use radian mode right now, okay? My Algebra 2 students are going to be using radian mode, and that's when sometimes if you do get a calculator and you don't check that you're in degree mode, that's why your numbers are going to be off, okay? So scroll to the right and make degree highlighted, and then press enter. And you see radian is no longer highlighted there? Now you guys are in the correct mode. You guys got to remember to do this every time from now on when you guys use the calculator. Clear the memory and go into the mode. Make sure you're in degree mode. If you are not in degree mode, this is where your answers are going to be off, okay? So go ahead and hit clear now. And now we're going to find the buttons from the song. Does everybody see right above the 7, there's a sign button, the sin, and then the COS, and then the TAN. Those are the buttons we're going to be using, okay? Sine, cosine, and tangent. Now in the video, hopefully you noticed they did mention a few things about SOHCAHTOA. Now, we're going to go over that right now then, okay? So we're going to do this problem here. Now before we do this problem, let's go ahead and we're going to move past some of these pages real quick. And we're going to move all the way down to oh, I guess I didn't put it in there. Oh. All right, so we drew our 100-foot building, cast a shadow of 88 feet. And what we're going to do is we're going to find out what is the angle of elevation. Now, does everybody see the angle of elevation is from the bottom of the floor looking up? So in order for us to find this angle of elevation, we're going to use SOHCAHTOA. Now, I got to introduce to you so you're going to have to put this in your notes. That's going to be the sine of an angle is equal to the opposite, and I'm going to abbreviate it over the hypotenuse, okay? Now, does everybody understand that in this picture, the 90-degree angle was formed right here? Opposite the 90-degree angle is always the side that you would substitute for C, right? That's also called your hypotenuse, okay? I'll abbreviate it right now. The other two sides are called your legs, your a squared and your b squared. Remember at the beginning of the video, a squared plus b squared equals c squared, right? Now, because we're going to find this angle here, the side that's opposite that angle is called your opposite side, okay? The other side is called your adjacent side, okay? Now that can change. If I were to use the other angle that's in the triangle, does everybody see so far I've only identified the 90-degree angle and where the angle of elevation is? Does everybody see that there is an angle that I haven't referred to it, and that's the green angle right there? If I were to choose to find out that green angle, my opposite side changes. Opposite would be over here. Adjacent then would be over here. But you gotta keep that in mind when we're doing problems, okay? Right now, though, we're gonna do the angle of elevation. So that's my red angle, okay? So what I need is, I need to know out of the three sides, hypotenuse, opposite, and adjacent, I need 2 out of those 3 sides. Can you tell me which 2 sides I have? I have the adjacent and the opposite. Right now, if we were to use sine of an angle, I need the opposite over the hypotenuse. I do have the opposite, but I don't have the hypotenuse. If I wanted to, I could use the Pythagorean theorem and get it, but I don't want to do extra work. So that means let's go to cosine. Cosine of an angle, and I'm not writing out the whole word cosine, I'm just using the first 3 letters of the word cosine, the same as for sine. Okay. Cosine of an angle is equal to, do you notice it said CAH? Cosine of an angle is equal to A. A represents which one of these 3 sides? Adjacent divided by, what's the H mean? Hypotenuse. Okay, do I know the adjacent and the hypotenuse sides of that triangle? I do know the adjacent, I don't know the hypotenuse, yeah? That leaves us with the last one, tangent. Tangent of an angle is equal to the, what do you think? It says TOA. Tangent of an angle is equal to, what do you think? What does O mean? Opposite. Divided by the A means adjacent. So now are you guys going to forget SOHCAHTOA? No? Don't forget that song, right? Okay, I'll play it again if you want me to.
Please though.
All right, so sine, cosine, and tangent. So now you got to keep this in mind. You got to remember the initials that go with it, though. SOHCAHTOA. Yeah? Does everybody agree that sine does not help us? Okay. And cosine does not help us. It's tangent that's going to help us. Yeah. All right, so find some space in your room right there as best as you can. And we're going to do the tangent of an angle. Now, if you notice, I don't know what that angle is. And this is the angle that I'm talking about right here. I don't know this angle, but that's the angle I'm referring to, okay? Tangent of that angle is equal to the opposite, which measures how much? 100 over 88. All right. Now, to solve that for the angle, in math, you can't do divided by tangent here. Because that would leave us the angle. This symbol right here is called theta. And those are some Greek symbols that were used way back when Pythagoras started off, okay? And even before that, okay? So that symbol right there means theta. We're going to solve for theta, and theta is typically used to represent an angle. Remember in the last unit we used K to represent the scale factor? Just symbol notations, that's all there is, okay? All right. So instead of us dividing by tangent, we're going to solve for the angle theta. And to do that, we have to do what is called tangent inverse of 100 divided by 88. So now I'm going to pull up the calculator again. Put the calculator on the screen. There we go. Did I? Okay. Hello, buddy. Wow. Computer is not liking me today. All right, so we're going to solve the problem for tangent inverse. So now, everybody look at the buttons for sine, cosine, and tangent are. Does everybody see tangent? Tangent is right up. Tangent button is right here. It's right above where 9 is. Now, do you see right above, in white writing, right above that in blue writing, it says tangent to the -1 power? That's called our tangent inverse button. Let's go ahead and hit the blue button. Whenever you hit the blue button, only the blue things that are written are what you're going to use. So we're going to type the tangent button, and you should get tangent to the -1 on your screen now. All right, right there, we're going to type in 100 over 88. So you're going to write 100 divided by 88, and then you can close the parentheses like that. Go ahead and hit enter. Is everybody getting about 48.65 to do all those numbers? Okay. That angle measurement, or that angle of elevation, is 48.65 degrees. Okay. Did I get that? No? Okay. Did you get tangent to the -1? Now, did you write 100 and then the division symbol over 88, and then you close the parentheses? Yeah. Okay. Here's why you got that. Hit mode is radians highlighted. The reason why your angles are going to be off is if you're in radian mode and then you try to do second tangent inverse of 100 divided by 88. You see that's the number you were getting? And on the screen, it's giving me both of them. Do you guys see which one is the right one of them? You were in degree mode, or I'm sorry, you were in radian mode. Remember, I told you if you don't remember to do this from this point on, that's why your answers are going to be off. Okay? And all I'm going to be able to tell you is check your calculator, check your mode, check your work, because something's not right with your answer. Yeah, that's where the first problem is going to be. So this is why I tell you, we'll practice this several times as we're moving along. So the answer for the angle of elevation is 48.65 degrees. That would be fine, 48.7. So we would say approximately 48.7 degrees as our answer. Okay? Are there any questions on the one we just did right now? No? Okay, let's go to this next problem right here. See if you can draw a picture for that next problem. I'll get to it in a second. Says the chairlift at a ski resort rises at an angle of 20.75 and attains a vertical height of 1,200 feet. How far does the chairlift travel up the side of a mountain? So here's what you got to keep in mind. Chairlift starts at a point on the bottom of the hill. Does that make sense? Yeah? And it says it rises at an angle of 20.7. So do you guys understand that's an angle of elevation? So that means you got to draw a horizontal line, and your angle of elevation is not that big.
That's all right.
20.75 degrees, right? Then it tells you it attains a vertical height of 1,200 feet. So let's say the mountain, let's say there's the mountain, yeah? Do you guys agree that the height of the mountain is from the very top of the mountain to the very, whatever the bottom is? That would be, in my drawing, the highest height, right? Okay. So do you kind of have an idea of what we're going to do when we come to next class, when we're trying to find the height of the tree? Okay. If we can get the angle of elevation, and if we can figure out if I can find out one more of these sides, I can find the distance between me and the tree, because I can measure that. I can't climb up and I can't fly. Yeah. Now, does it make sense that the ski lift travels like that? Yeah. Okay, so unless I get on the ski lift, that's the only way I can travel that side, right, of the triangle. So what I need now is, it says, how far does the chairlift travel up the side of the mountain? Do you guys understand that it's asking you for this distance right here? How much, how long is that lift? So we're trying to figure out this side here. So in your picture, does everybody see the 90-degree angle is right here? All right, do me a favor, draw an arrow from your 90-degree angle to the side opposite that angle. That's called the what? Hypotenuse. You guys realize that's what it's asking me to find out, the hypotenuse? Okay. It says and attains a vertical height of 1,200 feet. Do you guys understand that's the height of the mountain? And that's the opposite of this angle that we know, right? That's the opposite of the angle that I know. It's really critical that I stress this out. Does everybody agree that the 20.75 is the angle that I knew? The side opposite is the height of the mountain. I need the adjacent or the hypotenuse. Which one of those two is the question asking me? It's asking me for the hypotenuse. How long is that chair? So now we're going to do again. So I'll go ahead and write it somewhere where you have some room to see it. So that's one. Yeah, play this one. Play it for a second. That way you don't forget. Never forget it. All right. Come on, computer. Make me look bad.
Yeah, you know what it is.
No. Soka-toa, okay?
Or you're gonna lose.
And this is what we're getting at. Sine is opposite over hypotenuse.
Why you look confused? Which one you gonna choose? Cosine's adjacent over hypotenuse.
Over hypotenuse.
Don't get complacent. Tangent is opposite over adjacent.
It's getting down. That's how I get down with math. Okay, so which one of those three do you think we can use? Which one of those three? Now look at the letters, S-O-H. So the first one, S-O-H, that sine of an angle is equal to the O over the H. So sine is O over H. C is cosine A over H, and tangent is opposite over adjacent. Which one of those three will help us? Tangent? Tangent will give us, we have to have the opposite over the adjacent. Now, do you notice we already know the angle, right? So we already know the angle. All we need is one of these two. Which one do we have?
The opposite.
Opposite. But remember the question is asking us how far does the chairlift travel? That's the hypotenuse, isn't it? So which one has opposite and hypotenuse in it? The first one, sine. So over here, go ahead and write sine of the angle, which is 20.75, is equal to the opposite. Opposite measures how much? 1200. Over the hypotenuse. Now the hypotenuse is what we're trying to solve for, so that's the distance the chairlift travels. Okay? Now take a look at this math. You can put an x there if you want to solve for x. Okay? Do you notice x is on the bottom right now in that equation? We don't want ever to have the variable on the bottom of the fraction. So let's get it out of that way first. So do you guys, what do you think I'm going to do right there to get x out of the bottom? How would I move x to the other side of the equation? Multiply. So everybody go ahead and multiply by x to both sides. Now, is it okay if I erase my mountain a little bit right here? Yeah. All right. Do you guys agree I'm going to get x times the sine of 20.75, and on the other side I'm going to get 1200 by itself now? We're okay? What if instead of sine of 20.75, what if it was just a number without that? How would you solve for x? What if, let's say it was, I'm covering this up. And I'm covering that up, and that was the number 3. It was 3x equal to 1200. What would you do to solve for x? Divide by 3, right? Well, instead of it being 3, it's sine of 20.75. So go ahead and divide by sine of 20.75 to both sides. Make sure you write this out in your notes. And x is equal to 1200 divided by the sine of 20.75. So now we need our handy-dandy calculator. Okay? So turn on your calculator. It'll shut off automatically, okay? So we're going to put 1200. Okay, 1200 is in there. Now we're going to hit the division button. And you got a little bar right there. Do me a favor. I need you to put a parentheses here. It's right above the 8. Put the beginning parentheses. Okay. And now we're going to type in sine. So hit the sine button. And there's another parenthesis popped up. So there's 2 parentheses, so you're going to have to close it with 2. Okay? What number should go in there? 20.75, go ahead and type 20.75, and we need 2 parentheses that close it. That means the one that's above the 9. Okay? 1, and then 1 more. Everybody with me? All right, go ahead and hit enter. We should all be getting the same number. No? No,
3387.
3387. Let's make sure in my mode.
Yeah.
I didn't switch it back. Caught me! Caught me. So what's the number you guys are getting? Because you guys all got the right number. I did.
3387.0458.
Say it again, tell me.
3387.
3387.
04.
04, okay, that's good right there. And that's in what type of units? Inches, centimeters,
No,
feet. So that chairlift travels that far, 3,387.04 feet. So let me make sure I put it in the calculator for those watching the video. The number I got was wrong because I was in the wrong mode. Sine of 20.75. Good thing you guys caught that. Oops. If this error pops onto you, if you hit one, if you leave it on one and quit it, it won't tell you. If you scroll down and hit go to, not got to, go to, it'll tell you where there's an error. And there's an error there because I didn't have two parentheses at the start, and I put two parentheses, so I need to delete that third one, or that second one. Okay? The calculator is only as good as you guys practice and get good at it. Okay? So right now you're learning how to use this, okay?
Why in our equation did you make us put the parentheses after the division?
Just because I wanted to make sure everybody realizes when we're doing division and there's a bunch of stuff on the bottom, you gotta make sure all of that is inside of a parentheses. Yep. All right. So I just wanted to keep that as a habit. Hopefully you keep that. Okay. All right. So that I could actually round that off to 3387.05. Does everybody see that? So that really should have been a 0.05 right here. And does everybody see that the number behind the 4 is a 5 bigger? Yeah. All right. It says the angle that rises from the chairlift was 20.75. The height that it attains, which is the top of the mountain, that's 1,200 feet. How far did the chairlift travel upside the mountain? That was our hypotenuse. Okay. All right. Let's see if you guys can set up something for example number 3. You got to do a drawing. Okay. All right, so it says the angle from the base to the top of the water slide is about 13 degrees. The angle from the base to the top of the water slide. So do you guys agree your drawing should begin somewhere down here at the bottom? And I would say start at the far left. Yeah. So start at the far left. There's a starting point here. From the base to the top of the water slide. So whatever this water slide looks like, it's a certain height, yes? Do we know the height of it? No? Okay. From where we're standing, or where we started the drawing, is that the angle that I'm drawing, the angle of elevation? Is the angle I'm drawing the angle of elevation that they give me? 13 degrees? From the base to the top is 13 degrees. That's your angle of elevation. Or a hint, it told you, from the bottom to the top. So do you guys remember when we went outside? You went horizontally and you started looking up. That was angle of elevation. Yeah. Now, if it was an angle of depression, it's something looking down. So you got to get a better perspective of what you're actually drawing. Right? So that's really 13 degrees. Keep in mind, whenever we put angle measurements, those will always have the little symbol that looks like an exponent of 0. That means degrees, okay? Not to the 0 power. Okay. All right. The slide extends horizontally about 58.2 meters. That number, you guys agree, 13 degrees, the side that's opposite, that's the opposite side, right? The bottom is the adjacent, and over here always is the hypotenuse. That's your 90 degree, opposite your 90 degree angle. Where does 58.2 go? It's the adjacent. Now watch. It says the slide extends horizontally about 58.2 meters. So that means, does this make sense? The slide, have you ever been in those jumpers? like the ones they're gonna start having pretty soon for the Halloween, maybe for the little kids, you know? And the kids climb up to the top of the thing, and it's a pretty long slide. Like, I think they already have it over there by the pumpkin patch that they're gonna do off the Bear Valley. And they start at the top, and it's like, you know, it doesn't let them go. It's typically they're not all just straight, because they'll start to get a lot of momentum if they're going too fast. And they usually make them like this for kids because they don't want them to get so much momentum when they reach the bottom of the slide that they can't stop. So it's a safety issue. So do you guys see that the slide extends horizontally? That's the adjacent side. So make sure you label that the adjacent thing is 58.2 M. And M is an abbreviation for meters. Okay. What do they want me to figure out? Do they want the opposite? Do they want the hypotenuse? Read the question. The height of the, so that we want the opposite. So we need something that has adjacent over, adjacent and opposite in it. So you've got to try to figure out, okay, what has adjacent and opposite in it? Torah. Okay, so let's write Torah. All right, Torah from Sukkah Toa. Toa is the one we're going to use, okay? We know the angle already. Does everybody agree that was the 13 degrees was given? So we know the tangent of 13 degrees is equal to the opposite. Do we know the opposite? You can, and if you want to, you can label that X if you want, okay? Do we know the adjacent? Yeah. 58.2. Really important that you give whatever numbers that they give you as best as possible. Okay? All right, now look at that problem. You're going to solve for X. X represents the opposite. Make sure in your notes you wrote opposite is equal to X. So when you solve for X, you already know you're solving for the opposite side. Okay? What do you think I can do to get X by itself? Notice it's not on the denominator. So how would I solve for X then? Because I got to get that division of 58.2 on the other side. How do you undo division? Multiplication. Go ahead and multiply by 58.2 to both sides. So now you're going to have 58.2 times the tangent of 13. Okay? On the calculator, you can type it a couple different ways. You can type in tangent of 13 first, but you got to be careful that you don't do tangent of 13 times 58.2. Okay, so let me show you a couple scenarios that can actually happen here if you do it wrong. If you type in tangent first, and then you hit 13, if you don't close the parentheses right there, and you hit times 58.2, and then you close it, do you guys see that you just made the angle bigger inside of the parentheses? And your answer is going to be off, okay? If you do that, look at what happens. I get a decimal down here, yeah? Now, does everybody understand that what I just typed into that screen is wrong because I didn't close the parentheses when after I typed in 13? Okay. So the tangent of 13, you should have closed it, and then you could have hit times 58.2. Okay. You also could have done 58.2 times tangent of 13 this way. Okay. So what does the measurement for the height of the slide give us? 13.44 meters. Yeah. Now they're giving you them in meters, okay? Not feet, so don't see, oh, 13 feet, that's kind of small, because you guys are typically used to feet when you're looking at things, you know. If you were to say the height of this classroom, you'd probably use feet to figure it out. You probably wouldn't use inches because they're so small, you'd have to use a bunch of inches, yeah. Notice you're not going to use miles or kilometers to measure the height of this classroom, because miles is way bigger than this classroom. All right, so we've got those examples. So now, when we go out to the outside, when we do the height of the tree, you guys realize we're going to need to get the angle of elevation that we're looking with the planometer, and then we're going to have to figure out what's the length between you and the base of the tree. Yeah, but you got to keep in mind, the length from you to the base of the tree should be a horizontal line. Okay, so we got to make sure we go back right now and find out where is the horizontal line. So, everybody grab your clinometers, we're going to go back out there. You guys excited? Yeah, I'll do this.
Hey there, my name is Bob, and I'm a log. I'm not a mathematical type of log. Those are exponents. I'm just a piece of wood. Today, I've decided to leave my home in the trees and go on an adventure. Legend has it that there is a secret, mysterious treasure somewhere near here. So, hopefully, if I look around long enough, I can find it. Let's go! There's no way I can jump that far. I'm gonna need some help to get over this thing. Who are you?
Hi, I'm Sign Guy, and I'm the sole part of Team Sophatoa. If your sign S with an angle of a triangle equals the opposite side O, divided by the hypotenuse A.
Hey there, I'm Cosine Guy, and I'm the co-part of Sophatoa, because cosine C equals to the adjacent side A, divided by the hypotenuse H.
Hi, I'm Tangent Guy, and I'm the total part of Sophatoa, because tangent T equals opposite O divided by adjacent A.
What are you doing here?
I'm here to help.
Using my trusty hang glider, I can fly a distance of 0.75 units, but I want to make sure I can make it before I try. We know that that sign forms a right angle with the ground, and that its top is 0.5 units off the ground.
I can tell you that the tangent value at that angle is root 3 over 3.
Tangent equals opposite over adjacent, so root 3 over 3 equals 0.5 over the adjacent side. Solving this gives root 3 over 2, or 0.866, to be the length of the adjacent side. That means that my hang glider won't reach. My only other option is my reliable grappling hook, which can fly in a straight line for exactly 1 unit. The only problem is, the only place I see that it can attach is the top of that sign. I know we can use the Pythagorean theorem, a squared plus b squared equals c squared, to find the length of the hypotenuse, but... Wait, there's an easier way. With those measurements of that triangle, we know that this can form a unit circle. The radius of a unit circle is 1. So from here to the top of that sign is only 1 unit. We can make it.
Yay!
Wahoo!
What?
Okay then. If I try to go up an incline that's greater than 45 degrees, I could roll down and hurt myself.
I can tell you that the sine of that angle is 0.7.
But how can we find the measure of the angle when all we know is the sine value? When you want to find the angle measure, all you know is the sine, tan, and cosine.
That's what we're gonna be doing.
You know what it is. Toa, something, toa, something, toa, something, toa. Yeah, you know what it is. Something, toa, something, toa, something, toa, something, toa. Yeah, you know what it is. When I'm doing math, I do it big. Yeah, that's nothing. When I'm doing math, that's nothing. When you see me in the class doing math, I'm using the toa, something, toa, something, toa, something, toa. Put it down from the right one to my open. You're gonna dream big kills or you're gonna lose. Sine is opposite of what hypotenuse. Why you look confused? Which one you gonna choose? Cosine and taking over hypotenuse. We're not done yet. Don't get confused. Tangent is opposite over adjacent. Yeah, you know what it is. When I'm doing math, I'm doing big. Yeah,
That's what we did. Actually, now you're in.
Well, I have one of these.
So you already did tomorrow's.
Yeah, I'm
You did
using
tomorrow's.
mode. I'm telling these problems.
I already did unit 3.
So you need the handouts for the first, on Monday. So you got ahead right now.
Okay.
Which is fine, because the other stuff then should be super easy.
Okay.
Yeah, and the video should be that also. Sorry.
So just want to
Yeah. Have that done though. Sorry about that, Mom.
No, that's fine.
Misplaced it. Asia. Here you go.